Hi, I'm Michael Chow, and in this screencast, I'm going to be doing a data analysis in Python over data I've never seen before. The data comes from the Teddy Tuesday project, which is a project where every week they upload a new data set, and then people can analyze it and post it online to compare what they've done with others. So I'm going to go ahead and open it up and go to the most recent entry, which is on the avatar. Um, Okay, so what I'm going to do first is I'm just going to pull the data into Jupyter, and then I'll look a little more closely. So the key is they have these read CSV commands, so we can see there are two data sets. So I'm going to go ahead and pull it. Let's see. So I keep my Python in virtual environments, which is why you saw those to show you all these boxes. Each of these is a virtual environment. So it's basically a sandbox where I keep different Python packages for analyses. So I'm going to go ahead and import pandas, read it in. Okay, so that's got 13,000 rows. Let's grab the other one. Okay, so it's right here. Grab this. All right. Okay, so this is, it looks like the core data set, which has who's speaking, the text they speak, and books. So I think in Avatar, each season is a book or something close to that, and then each episode is a number. Ooh, or something near that. They're sort of like books and chapters are sort of like similar to seasons. And then the director. Okay, so I'm guessing each row here will be a. Well, it says 13. Let's see. All right, so I'm just going to give these names and look a little more closely. So I'll call this avatar. Since it's named avatar.csv, I'll call this scene description. All right, and then we can look a little more closely here. So once it reads, okay, so this is 13,000 rows. I'm going to check to see how tall this one is. This is 7,000. Okay, so avatar, this is going to be more than, each row I guess will be probably when a character is speaking, and a character or a scene description. So it's basically the full, it looks like, transcript for the episode. And then we have book number, chapter number. So I think that, it must be book and chapter must make up an episode. We can check that actually. Let's see. So this must be the episode name. So let's just go ahead and count. So what I'm going to do is I'm going to be using siuba. I'm going to import it above so I don't have to. Well, we can just toss this in. So I'm going to import some verbs. So these are basically things that can operate on our data. So what I want to do is I want to do a count. And I want to count, I'm going to count book and chapter. Oops, I need to put an underscore. So this is how siuba works, is you use this underscore to represent your data. So this is essentially, I'm saying kind of like avatar.book. And then count tallies up each entry. So, right, all the cases where book and chapter are Earth and Appa's Lost Days. So I think what this gives us is maybe all of the transcribed speech events or like scene descriptions. So there are kind of 106 episode kind of occurrences. So if we look, and I'm going to filter where chapter is Appa's Lost Days, we get back the 106, it looks like, events that happened. So this is, it looks like, so the scene description, right, where the episode begins, and then character speaking, and all that. It looks like we also have info on the writer and director and IMDb rating. Since these occur only per episode, but this is per like speech event, these are duplicated across all the rows in an episode. What we could do is Sua has a distinct method. I'm just going to do it here so we don't. I'll pull these up to get the individual writer and director. So we could do book, chapter, writer, and director. And this will give us back ideally one per episode. So here we have 61 rows. So hopefully that's the number in Avatar. And I think there were four seasons. So this would be about 15 episodes per season. Cool. And then, so something we could do is then we could count, say, book, right? And we see, actually there were maybe three seasons and 20 episodes. I'm not totally sure if these are seasons or if they could span seasons, but something similar to that. All right, so I'm going to name this to be maybe episodes. And we might even end up pulling out some more info from Avatar. And then let me put the count here so we see how many books. We could also, right here. So we see there's 20, and then there's also, we could do book by chapter. That won't. I don't think that'll tell us anything new, but because there's only one observation. We could count the writer and see, okay, so quite a few different writers, sometimes combinations of writers. I think, let's try this. So let's see, and then I just want to see the most common that occur. All right, so it looks like John O'Brien wrote the most episodes, and there are some that only did one, it looks like, though. Another important thing is that sometimes there are multiple writers, so we could split it. And the way to do that is, so what we can do is, I'm going to mutate. That means to create a new column. And what I'll do is I'll take the writer column and I'll do string.split. I'm going to call this maybe all writers, or split writers. Notice that it returned a list here. So that's pretty useful for being able to see. And then the last thing we can do is, let's see if this works. What's the right way to do this? All right, I'm going to do split episodes, and just to test, I think we can do all split writers dot explode. Is that, yeah. And I wonder if we can do it on the data frame too. Let me try. I don't think we can. Oh, we can. Nice. So what this did is it basically took that split data frame that was a list of writers, and it made each writer, so each entry in that list, its own row. So now we have one row per writer rather than comma separated. This lets us count. So now we can actually count the writers, including when they're working together. So let's see. All right, so we can see now John O'Brien has 11, where before they had 10. Right, so some of these people may be it could be that some writers collaborate a lot, so we wouldn't have counted them before. Cool. So I think that's kind of interesting, I guess, to see. I'm gonna hide this output since it's not crazy interesting. I'm gonna just actually probably combine it here. The one thing, so we looked at writers. Let's see. So I'm gonna go back to the avatar data just to think about what else might be in there, because there's a lot of stuff. So we have the ratings, we have directors, and then we have this whole thing about each character, what they say, and that's quite a bit to dig into too. I think it could be nice just to start with the ratings, which is pretty simple, and go from there. So I think the one last thing I'll do is I'll also count the director just to see what's going on. Okay, so there are 6 directors. I think actually this person, did I see them in writers? Nope. Yeah, okay, so interesting. It looks like there's 7 directors, because this starts at 0. And it looks like one director in particular has done quite a few episodes, about a third of them. All right, so I'm also going to maybe make a header here, which is episodes. And then I'm going to actually make another header, which is writers and directors. And then down here, I want to do maybe what do ratings look like over time, or maybe to be more specific, when did the show have its highest ratings? Okay, I think this is useful because just saying ratings over time is actually a pretty generic question, whereas this one is much more specific. It could have actually a specific answer, right? There's a specific time when the show had its highest ratings. Okay, so I think we have here. Oh, we need the IMDb. I think it's called ratings. Let's see. Oops, let me print avatar. Yeah, IMDb rating. Actually, one other thing I want to do is siuba has an experimental completer now, so should be able to do auto completion, and I'll show you that right now. So essentially, it's that if we run something like this, and then we want to know, it might take a second. Oh shoot, maybe not. Oh, there we go. So notice I can let's see. So if I run avatar, then and I look here, and then I press tab, it will try to autocomplete. So IMDb rating. It's not perfect yet. So this was implemented by Tim Mastny, and we're still working out some of the details, but it's handy to be able to tab and look through autocomplete. So that's IMDb rating. Let's see. All right, so now we have it. And we can just do, let's just look across here. I'm going to, I'm going to just do something. I think this will, episode number. So just, Oh, I thought that, let's see. So, yep. So we'll just get this index, and then I'm just gonna ship it to ggplot. So we'll do index and IMDb rating, and then geom point. Oop. Oh, so I need to import plot9. Oop. Okay, so now we have everything from plot9. Oh, there's a missing value on a rating. Let's see, episodes, filter, IMDb rating dot is NA. Yeah, it looks like for some reason, oh, this is it may be because it's part 2 of an episode, I don't know. Yeah, in any event, it seems okay. So let's see. We could actually just open IMDb and check this too, if we wanted to look a little more closely. So let's see. I'm gonna color it by book. Okay, there's some warnings. I think these are compatibility with plot9. I may need to upgrade plot9, or it might need some updates for the newest pandas version. All right, cool. So these are, so notice that it goes book by book. So it starts with water, then it goes to earth, and then fire. Let's see, and so the IMDb ratings look like they generally increased over time. I think actually we can do a line might be a good idea here. So just to connect everything, I'm also going to do black formatting. Although it didn't work out as quite as I had hoped. All right, so it looks like they increased over time, and then, but there were some kind of surprising, like this one has surprisingly low ratings. We could, if we wanted to, we could do expand limits so that Y covered the full scale. This kind of compresses it. You might, sometimes I do it at like 5 or something like half of the scale if it's really high, but this is useful, I think, for seeing in context. So this one is quite a bit lower, looks like, than the others. I'm going to pull out. So what I'll do is I'll grab episodes where IMDb rating is the minimum. IMDb rating dot min. All right, so it looks like it's this one, the Great Divide. We could look it up and see. Let's see what's going on here. Oh wait, I need to probably put avatar. Let's see. Avatar. All right, so let's see, episode. All right, so they have to help 2 feuding clans cross a dangerous canyon peacefully. Yeah, I wonder why. I'm not sure why it was lowest rated. Let's see. No hot takes. Oh, here we go. So, let's see. Well, that's okay. It's opening, taking its sweet time, and then the ending maybe. So he's pompous about it. Maybe it felt kind of. Maybe people felt nuts that the character had to lie, and maybe it was predictable. I don't know. Um, huh. Yeah, I'm kind of curious. Um, so that's kind of interesting to note. And then otherwise it looks like the highest rated tend to be the ones at the end of the season, the finale, and the very last episode. Looks like this one. I mean, the one other thing is it looks like this season really had a rocky start. Right, things went downhill and then they picked up. Um, One way we can capture this is we could also get the episodes where um, there's the biggest difference. So the way you would do this is shift. So notice this one shifts the ratings down. So that means like if we just shifted IMDb rating, each row would have the rating from the previous row. So what we could do is filter where IMDb rating minus IMDb rating dot shift. So that's where the current rating minus the previous episode's rating. Or let's mutate it. So we'll do rating diff. I think actually there's a pandas method to do this exact operation, but this should work okay. And then we can just get the max rating diff. And one thing that could be interesting too is doing a group by. So let's group by book and then filter to get where rating diff is at the maximum. So rating diff equals the max. I'm gonna do black formatting here so it's on different lines. Cool. So now we see these are these points probably. So this one and this one. One thing to keep in mind is that this is when the next episode or the current episode is greater than the last episode. It doesn't account for the other way. We'd have to do an absolute, but it doesn't seem to be an issue here. So this is just the biggest increase. And I'm curious about this one. So this is for fire. So the invasion. So maybe it's let me just grab the fire episodes. I wonder if it's like if it was a lot of build up to this kind of episode. So I'm gonna do book is fire, and then I'm gonna arrange it. I need to import from siuba the arrange verb, and I'm gonna arrange by I gotta reset index, and then I'll arrange by index. I think I gotta put it in here, access it like because I think dot index is a pandas property. So if I do episodes dot reset index dot index, that actually gives me not this column but the special pandas property, the index, the thing's shown here. So it's kind of a weird dynamic, but using this style you can always get out a column of the data frame. So I'm sorting by this index column, which should order these. I'm guessing they're already ordered, but just to be safe. So then we can see, so 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So this, I was expecting this one to be, so this is definitely, this goes from a 7.8 to a 9.1. I thought that this would be right here. I'm a little, oh, sorry, this is Earth. So these colors, I think the red, I was thinking of fire. Let's look at the earth one. So this is the blind bandit. Let me go to earth. So this is leading up to basically, this goes down, 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 down in terms of ratings, and then it goes up for the blind bandit for some reason, which is kind of interesting. It doesn't look like this is the first time even this director showed up, but it looks like this writer's first time in this season, so maybe that's remarkable. So yeah, maybe someone with more knowledge of the Avatar knows kind of what went on here. Actually, I've seen the series. Maybe there's like a lot of traveling. I think there's a lot of traveling and stuff here. All right, so that's interesting. So basically I'm gonna comment this out and just chuck it up here. So we just pulled out kind of the biggest, where there's the biggest difference in ratings. And we also looked at the kind of like minimum rating. Another thing we could do is we could look at writer, like the ratings for episodes that a writer was on. I think for that we'd still want to use this split version where each writer is a row, even if it means that there are multiple rows per episode. So, that would be split episodes dot explode, split writers. So that could, I'm kind of curious to see that, which writer was on, or which director. Let me think about this a little bit. Because the one thing we could see pretty easily is, actually in this plot, it'd be quick to add director info. So let's try that first. Excuse me. So these are our titles. I'm going to go and add a new heading. So which director had highest ratings? All right. And I'm just going to plot the same thing, except now I'm going to add, let's just do, this will be too complicated, we'll need to change the plot, but let's add a shape for director. Oh, that did not work. Let's see what's happening here. Oh, it's grouping. So we need to add a custom group here to be, we could either group everything together, or, yeah, that seems fine. That actually, I'm surprised that these points didn't connect. Notice how these did. I'm not totally sure what's going on. Oh, group O's not a... Okay, but in any event, that changed the director, gave it a shape. This is too hard to see. One thing we can do is we could facet by director, or we could use a color. So I would say actually just changing color to director will be a lot easier to see. And maybe getting rid of the, let's do group. Maybe getting rid of the line. Yeah, so here. Not great. The other thing we can do is we can aggregate. So let's see, or facet. Let me try faceting real fast. I'm guessing we might need to aggregate. So director. Cool. This is helpful though because we can see now, like Ethan Spalding came in later. I should get rid of the shape. I mean, it doesn't hurt. This person was there at the very beginning. Same with Dave Filoni. And then some, yeah, it looks like some came in at the end, and then some were here sort of through the whole thing. It is kind of hard. The one problem is it's hard to compare. Here you can see really easily what's going on the x-axis. So you can see that some people are there only towards the end. You can't. It's hard to kind of compare vertically because this it's a pretty subtle, I think, effect. None have like awful episodes, right? So what we can do is we can aggregate it. So why don't we go ahead and try that? So episodes by director, and then let's summarize just to get the. Well, we could also do a box plot. Let's just do this. Yeah, let's do this really fast, and then so I'm gonna do IMDb rating dot mean, just to get the average rating, and should be fine. Oops, need the summarize verb. Okay, so here's the IMDb rating, and then we can do like a bar chart if we want. So let's do director and then mean. Oh, I should do maybe average. Let's give this a better name. Average rating. Oh, I need to add the geom call. Great. So not the most exciting plot. And then often you want to flip this text. We could also do a chord flip though, and that will just put them here. So we can see, and then another thing I like to do is order it. So what you would do here is use director equals, I'm going to use a tool from siuba called FCT reorder. So this basically reorders values. It creates a pandas categorical, and that's a thing that lets you kind of set an order to the values. So we can order the directors. So I'll do FCT reorder director by average rating. Oops, import. Okay, so now notice that these are ordered from highest rating to lowest. So, okay, so we can see there are, well, I mean, not necessarily like meaningful differences. Number of episodes is kind of important here, things like that, but we can kind of see some of the range, right, in terms of average rating. The other thing we can do is just do a box plot, and that will help us see some of the variation too. So just get rid of this, get rid of all this. Box plot, let's not do chord flip yet. What? Oh, IMDb rating. Okay, and then do I want to chord flip? I don't know. So I'll do axis text x, I think. Let's see. Yeah, equals element text. We can angle the y-axis. That's not the best. So notice that these ticks kind of go right to the middle of the text, and that's kind of hard to read. It's easier if this is on the tick, so I'll do that's using hjust equals 1. Okay, so now they kind of line up. I think it's better flipped, maybe. A bit more natural to read, but it's nice to have the y-axis be a numerical value. Okay, so let's do, I'm going to expand limits again. We could put it between 0 and 10. We could also maybe cut it off at 5. Let's do that. Cool. All right, so that's useful. We could also maybe we could order them by when they occurred. So the way to do that would be something like mutate, and then let me look at this. So what I'm going to do is I'm going to reset index, and then I'm going to mutate by I want to order them by, let's say if we take the median of the episode numbers they were in, we can order them by, right, who was sort of like in the earliest episodes versus later episodes. So we do that using the same FCT reorder. Let's do this, director by index, and then by default it takes the median, so now it will order from earliest to latest season. Yeah, let's do that. Oh, I guess it was already didn't make a big difference, but yeah, interesting. So it looks like maybe the early writers weren't doing as well. It'd also be helpful to actually just view how early someone was in general. So we did have it up here in this plot, right? We can see that these two are earlier. Yeah, maybe that's good enough. Just being able to look here and see that these two were early on and these ones were later is helpful. Yeah, okay. So the one interesting thing is these two were also there early on, but they stuck around the whole time. So I think that's useful to note. And it could have been also, I think the key is too that it might not be that these people were low performers, right? Low performing directors. It could also be that actually early on the show had lower ratings, and as it became more popular, maybe the ratings went up. All right, I'm not sure the relationship there. So it's kind of, I think you have to be a little bit careful about the causality here, which is not necessarily that the director caused low ratings, but that maybe being early in the show's run, right? Like in the first episodes of first season, the show had lower ratings because it was just getting traction or something. All right, so let's keep moving. So that's directors. I'm gonna add some labels here. So director ratings across episodes, ordered by maybe like ordered by like how early, by when they worked. That's maybe an awful title, but it'll work. So yeah, okay. And then let's see. So that's nice. I'm gonna add a label here too. So labs is average director ratings. I've got to be careful. I have a bad habit of being inconsistent with titles. Title. Cool. All right, so we've got which director had highest ratings? That was looks like Michael Dante DiMartino. We can check. Okay, so that person had a single episode, so maybe that's not the most exciting one for us. Actually, what we could do here too is, and something that would clarify that is, when we do the summarize, we could also do n episodes, and there we would do dot size should be okay, I think. I can't remember if it's a method. Let's see. Let's see. So there's something funny about how size works. I think let's do IMDb rating dot size. We'll see how that works out. So let me yeah, okay, so size isn't a method. It just tells you, it returns the number. In this case, for number of rows. If I'd done it for the data frame, actually it's the total number of entries. So that's important to remember. All right, so actually here, instead of using geom_call, now we can use geom_point, and we don't need chord flip. We can do, let's see, n episodes, average rating, and then let's color by director because there are only a few levels. Okay, so now we can see a little, it's a little harder to match up now director with the point they correspond to, but the advantage is that we get to see number of episodes. So it's now we kind of avoid this having one person who has only a single episode. And I'm gonna set the limits again, black format. So this is, I think, pretty helpful. I'm gonna set the limit to between 5 and 10. The other thing is, if we wanted, we could label it. So let's see. Oh shoot, is it label? I think. And then add a geom text. Yep. Whoa, excuse me. So yeah, it's not the best, and you might want to. So you can do I think oh shoot, I forgot I think it's yeah, so you can change the alignment. So horizontal alignment equals right. That'll put to the right of the point. Oh, nope. Left. So that's like what it's anchored to. So left touches point. It's not the best. We could also maybe decrease the size. This actually will be tiny. That was my bad. I think 6 is the default. Nope. So then it's a little easier to read. The last thing we could do is I think it's label. Yeah, and that might be a little better, where this kind of then makes up a point in its own right. And oops. So now it's kind of like it's a point, and we can see where each person sits and their number of episodes. It's kind of a funky geom. I don't know. I don't love it, but putting this much text on plots is kind of hard. So I'm gonna leave it like this. I think it's helpful to have this info and to see like, oh, this person has really high ratings, but they did very few episodes. This person has pretty good ratings and they did like a decent number, right? Compared to say this person. All right, so let's keep that. And then, okay, so we looked at director by average rating. We could look at writer. Let me go ahead and look at the avatar data again. We could also look at which characters show up. For example, like when is a character first introduced? That might correspond to some interesting ratings. We could look at, again, the question of writers. Like, are there some really killer writers in the cast? The other thing is we haven't looked at scene description yet. So this is just actually those individual rows describing when something happens. I'm kind of curious about when a character is introduced. Like, when a character is introduced, does the episode have higher ratings, or do episodes with certain characters tend to have higher ratings? So let's see, or maybe like the number of, like how involved a character is. We could count up how often they're used. So, I mean, what we could do is let's count up. Keep this here. I'm gonna go down. So now I'm gonna go to start a new section. This will be characters, avatar characters, and I'm gonna add this. When does a character first show up? Okay, and then so what I'll do is I'll look at avatar, just so I can actually also know how involved they are in an episode. I'm just gonna count character and not ID. We need book number and chapter and chapter number. We could also grab the book. So nice. So this this will give us one row per character per chapter, basically, inside a book. So kind of one character per episode. We also want to keep the IMDb ratings. Oop, that's not right. Oh, excuse me. So okay, so we know like how often they occur in an episode, and we can tell when they first show up. So the way we could tell when they show up is doing something like so character. I call this characters. I think what is it called? I think it's .is duplicate or duplicated. Yep. And what you do is let's see if this takes subset. Yeah. So we can ask character, is character duplicated? We could do it like this though too. So I think this works. Just use the series method, and it does the same thing. Which I noticed. Yeah. There's a slight difference. Let me see what's happening. Character. Oh, so this one has a name attached to it. Because it's a series method and it returns a series, just for some kind of internal pandas reasons, it does this. All right, so the key is that when they're not duplicated is when they first appear. And I think we can do last. Wait. So the first instance where they're duplicated is let's see. So I'll accept the first, I'll accept the last. So I think we do want I me think about this. So yeah, we want when duplicated is false, basically. So this would be their first occurrence. So first appearance is not duplicated. Cool. And this makes sense. This is the first episode, so this farmer is getting their first appearance. We might have to pull out some of the main characters. Let's see just how many characters there are. I'm going to sort it. We can use this to just cut out a few. So I'm going to look at the top 10. I need to... I'm going to black format. Okay. And then this might be okay. So maybe we look at these characters, or maybe we do 12. I think it... or 15. Yeah, let's do 12. And the best way to pull it out might be something like, let's see. So I think siuba, I might actually have to push this. Siuba should be able to, you know, there's a small improvement to siuba I need to push, but I think we can do this. Yeah. So this pulled out character from the data frame. I'm gonna also do, I'm just gonna do this. And it looks like, so this is most common characters. I want to exclude, so not dot character dot isn't, scene description, and get rid of guard and soldier. I think otherwise it's okay. So let's do, I'm gonna change this so it's shorter. All right, so we got the common characters. Did I leave someone? Nope. Okay, so this looks good. And now we can ask for these 13 people. Let's cut out. Wait. Let's cut out Hakoda. Also, because just so we have 12, I think it'll be a little easier to visualize. Although let me double check just to see what where that person showed up. Yeah, this person showed up nearly last. So what we can do is let's take a few less. Okay, so now we have 12. The thing is that we can show that in like a 3x4 grid of plots. Okay, so these are the common characters. So let's first plot when they first appear. So that'll be characters. Wait, what's happening? So, this is wait. So we want let me split this out. So into two data frames. We want one that is when a character first appeared. That's a different question than okay, so I'm gonna split this out into first appearance. Okay, that's all right, close. There's a parsing error somewhere. I think this, I'm not sure where it is. I'll have to look. oh, it's here, first appearance. All right. And then because we want here to, I'm gonna create a console just to test some stuff in. So, oops, let's put this. Okay, struggling. Okay, so gonna put this here, and then so I'm gonna copy this out, run it. Okay, so appearance. All right, so now we have first appearance, and then we just want to filter it. Filter when first appearance is true. And then this is actually, we want the original data, the characters data. Okay, so now we have when they first show up, first appearance, oops, and then we have, no, this is 372, so this must be, there must be 372 characters. We can double check that in a sec. And we just have when it's their first time showing up. I'm gonna double check. So characters dot distinct character. Yep. So okay, great. And that means we can, so basically the two things I want to do with that is I want to plot when a character first appears, and then I want to, and I only want to do it for the most common. All right, so actually we can, yeah, okay, so what this means is, let's do this then. We'll filter this to be common characters. Character dot is in common characters. So now this should only be, this will be every, yeah, so now there's only one entry per character, and we know the book number and the chapter number. All right, great. So then I'm going to, did I need to, yeah, so now I'll, okay, let's just plot this right now actually, and then go from there. So first appearance to ggplot, we want to know by, let's say by book number. No, we need we'll need an overall index. So let's just do reset index again. So by index and by, let's see, let's do IMDb rating. Wait, what's happening? So, okay, let's do character. Shoot. So, and then index where they occur, just to get this off the ground. Oops. And then it'd be helpful to actually do this the opposite. I'm gonna chord flip it just because I like to put the quantitative variable on the y-axis. All right, so we can see right, A and Azula show up right away. Ozai shows up way down the line. I'm actually, now that I look at this though, first appearance, we want to know the, I guess we want to know the episode number, but I think this is not actually this index. That's not right. It's let's do here we'll do we'll mutate, and then we'll do book number. How this works? So we need we essentially need to know the number of chapters per book, but it's also not the most exciting problem. I think that what we could do is just number it here in the original data. So what we can do is let's see, book number by chapter number. Here, actually, here's what we can do. So we'll do, let's facet by, facet wrap by book, so we can see which one they occur in. And then, oh, they all occur in the first season. Okay, so actually in that case we can just use chapter number. So this is when in the first chapter do they appear. Most of them so this can't be right though, because they almost certainly appear in I mean, a lot of these will appear in the first book. So, oh, I wonder if well, Aang definitely doesn't appear. He probably appears before chapter 16, I thought. Let me check. So Avatar, let's see who's in. Let's filter for Aang and see. Oops, did I misspell? Yep. Okay, so yeah, so Aang appears in the very first one. That means something went wrong, probably here. So characters dot duplicated. Let's try it just on, because we know Aang appears in this first episode, the boy in the iceberg. Let's just try it here. So dot character dot duplicated first appearance. I'll just do first since we're doing a quick check. Okay, so that looks good. This is not, we want the full, this actually might be ordered in different ways, but the avatar data, the one we're looking at, should be okay. All right. So the trick is that the characters data is a count, and actually the things it counted are ordered alphabetically, not chronologically. Whereas Avatar is ordered by episode chronologically. Okay, so that'll do it. And then let's see. So that's not good. Let's see, why do people have multiple first appearances? Because, well, there should only be one case where they're not duplicated. Let's see. Gotta pull up I'm gonna filter for, say, Zuko. Okay, and then this is bad, so a lot of first appearances. Did we do? We did not. All right, I'm gonna try this again, so just to see what might have gone wrong. Oops. Oh, we got this. Okay. I'm gonna filter for one character. Yeah, this is surprising. So, first appearance, is this grouped in some way? No, I don't think so. So, it does seem like it's grouping by, wow, lots of NANs here too, which is a little surprising. I think, I wonder, oh, I know. Oh, okay, this is real bad. So I pasted in the name of a data frame here, which is definitely not right. So that's the power of the underscore, is it lets you refer to your data without using other variables. So what I'd done is I put the characters data frame in here, which is works in pandas because it will kind of conform the indexes for the result. But this is why basically we use the underscore, so it knows we're referring to this data that we're operating on. All right, so all right, that should clear it up. Cool. So then it's funky that chapter number is represented like a numeric value, but that should be okay. So now this sort of matches what I expect, which is a lot of these characters were introduced right at first, and then some other characters were introduced later. I think notably, people note like Toph comes in, I think around episode 6, and that's kind of noteworthy. I actually thought Toph came in way later, but and then Ozai, the kind of chief villain, shows up way later, so kind of towards, I think, the very end of the chapter. So that's interesting. I was hopeful to check what it looks like when Toph comes in, and maybe as the last thing I'll do that. So I just want to see the episode, how that compares. What I'm going to do is just look manually because it's a quick check. So Toph comes in at the Blind Bandit. That's the Earth Book, chapter 6. So what we can do is just to take a quick glance. That's Earth Book 6. So 1, 2, 3, 4, 5, 6. So I think that's pretty interesting that when Toph came in, the show improved a lot. And so maybe we can pull that out by... Let's just get the Earth books to really drive this point home, and just mark that episode. So for the sake of time, I won't do it in the... let's see. So for the sake of time, I'm just going to actually manually do it here and note. So it's book number 2, chapter 6. So let's see. So episodes, book, chapter. So the really dumb thing we can do is we can just mutate to be let's do this. So sorry, I'm kind of all over the place. First appearance is Toph, and then And then here we'll do mutate when book equals Toph.book and chapter equals Toph.chapter. Oops, I need to give it something. Toph appears. Oop, and then 2 equal signs. Great. Oh, let's see. Oops, and we need to do an and here. The way this works is in Python you need to combine it like this. I think you use one and sign. Let's see. Oh no. So pandas arrays do some kind of funny things. So we just want to pull out this single value actually. So I'm gonna okay, I just need to do dot first, or we could grab it by location by using IAT, I think. Let's do that. IAT 1 or 0. This is grabbing the first entry basically. This is the worst. Okay, so Toph dot book dot at. Nope. Oh, it's like this. I don't use this function a lot. All right. So 0th entry. Okay. Great. And then what we'll do is let's so we could do size equals Toph appears. That might not be super satisfying. Yeah, it's a little bit funky. We could also just color it by when Toph appears, and that might be a little bit better. So it's kind of weird that so this is not the best plot I've ever made, but hopefully it drives the point home that when Toph appears, this season seems to get a lot better. This plot could definitely be improved, but let's stop there. So labs title is do things improve when Toph shows up? Cool. We could do size. Let's see. Toph appears. Oh geez. Okay, that's not really gonna work for us. So I think this is fine. We can stick here. It's not the nicest plot, but it drives the point home. So that's the avatar analysis. We went through quite a few things. We looked at different writers and directors. When shows had their highest ratings, and also the difference, right? The biggest difference. So like here to here. We looked at the different characters and we looked at average director ratings also, taking into account how many episodes they'd done. We used box plots to look more at the variance inside between episodes they did. And then we looked at when characters first show up in the series. So most everybody shows up in the first book, I think. I actually should validate that again, but some show up quite a bit later. So interesting to note. And then we looked specifically at Toph. Actually I'm noticing that Toph does show up a lot later in another book, so we would need to something we should do is probably facet wrap by book. This will be pretty messy, but it will get the point across. The other thing is that FCT I won't bother you with it, but the one thing to do would be to reorder this so that water comes first because it's the earlier series. And let's do it as my final act. I'm just going to do reorder book by book number. And then that should fix the order. All right, so now you see waters first. Right, so a few characters are introduced later. All right, so thanks for watching. Hope it was helpful. Happy to answer any questions, and hopefully I'll be able to post some more analyses and see you next time. Thanks.